Hello friends, welcome back to Codeviento. Today we are diving into two powerful and fundamental data structures, stakes and queues. These structures operate based on two key principles, last in first in first out. Let's break down how each of these works and why they are so important in the programming. Let's see how they work. First, let's take a look at the stake data structure. A stack follows the last in first out principle. Imagine a stack of plates in a cafeteria. When you add a new plate, it goes on top of the previous one. When you remove a plate, you take the top one first. And if you want the plate at the bottom, you must first remove all the plates on top. This is exactly how a stack data structure works. In a stack, there are three main operations: push, pop, and pick. Push a new element to the stack. Pop, remove the element from the stack. Pick, look at the top element without removing it. Think of a browser history. Every time you open a new page, it's added to the top of the history stack. If you press back button, you go to the last page you visited. Another example is undo function in text editor. When you undo an action, the most recent change is reversed first. Now let's talk about queue data structure. A queue follows the first in first out principle. This is just like waiting in a line at ticket counter. The first person to get in the line is the first person to be served. In a queue, there are three main operations: enqueue, dequeue, and pick. Enqueue, add a new element to the end of the queue. Dequeue, remove the element to the front of the queue. Pick, look at the first element without removing it. Think about a printer queue. Print jobs are added to the queue, and the first job to be added is the first one to be printed. Task scheduling in a computer also use queues. The first task to be scheduled is the first to run. If we talk about the real-world examples of stakes and queues, browsing history, undo functionality managing use stacks. Printer queues and message queues are all managed using queues. Both of these data structures play a critical role in managing data efficiently. Understanding how they work is essential for optimizing programs and solving complex problems. Now that you have learned the basics of stakes and queues, it's time to apply this concept to solve some real-world problems. We'll dive deeper into application where stakes and queues come into play. Until then, keep coding. Don't forget to subscribe for the next video. Thank you for watching, friends. Adios.